So in this video, I want to talk a little bit more about the why we would complete the square. It's not just something we have you do just to mess with you. It's a useful thing. So if I asked you to solve, for example, x squared plus 10x plus 16 equals 0, for example. The tricky thing about trying to get x by itself is you've got x that's in two unlike terms. Normally, when you're solving an equation, you would like subtract 16 and then divide by 10 or something to get x by itself. But how do you also take the square root to get x by itself? You see what I'm saying? You'd have to divide by 10 to deal with this term, but you'd have to take the square root to deal with that term. You can't really divide by 10 and take the square root at the same time. So what you do is you complete the square. And if you've watched the previous two videos, you'll see that I've got half of 10 is 5. 5 squared is 25, so I'm taking 25 away from 16 to get negative 9. Okay, you can draw the box if you want and see that you got 25 inside the box. You take 25 away outside the box. You need to take 9 away from 25 to match up with 16. Okay, so then if I try to solve this, what I've done when I completed the square is I had x's in two spots. Now I got x just in one spot. So I can do plus 9 to try to get x by itself. So I've got x plus 5 squared is equal to 9. Then I could take the square root of both sides, getting two answers. X plus 5 equals positive and negative 3. And then I can subtract 5 from both of those answers. So I usually split it into two versions here. Negative 3 minus 5 is negative 8. Positive 3 minus 5 is negative 2. I can double check that those answers by substituting them back into the original problem and double checking that I actually get an answer of 0. This one gives me 64 because two negatives make a positive. This is negative 80. If you add those three things up, it really does equal 0. Same thing with negative 2. Substitute it in, check that it equals 0. 4 minus 20 plus 16, check it out, you get 0. You would probably not have thought of the numbers negative 8 and negative 2 by looking at the original problem. But when you complete the square, you can see that there is some nice symmetry around the number 5. And I hope you notice that 8 and 2 are both 3 steps away from 5. Where does the 3 come from? The square root of 9. What I'm hinting at is that the completed square version right here lets me draw a nice sketch of the graph where we've got a quadratic equation with a vertex 5, 6, 7, 8, 9. We got a vertex right down here at negative 5 comma negative 9 swooping up like this, and the place where it hits the x-axis is at negative 2 and at negative 8. So completing the square lets you solve the quadratic, and completing the square lets you graph it a lot more easily. Okay, so I'll show you one more example just of solving it, and then we'll call it good for this video. Let's say I had x squared minus 8x plus 65 equals 0. Or sorry, I messed up. I want to do plus 17. I accidentally did 8 squared in my head instead of doing 4 squared, by the way, if you're curious why I changed my number. So I'm going to complete the square here. Half of 8 is 4. 4 squared is 16. 17 minus 16 is 1. Now I've isolated x inside the square. So I can go x minus 4 squared. Take away 1 from both sides is negative 1. Square root of both sides. Uh-oh. Lame joke again. You can't take the square root of -1, but I can. Square root of -1 is just the number I. So then you add 4 to both sides and you get your two answers. X equals 4 plus I, and your other answer is x equals 4 minus I. So the reason I wanted to show you this example is that you can use completing the square even when the answers come out to be complex. And if you look at the graph of the completed square equation, you can see why the answers are complex. I've got a vertex at 4, 1. I've got a parabola swooping up like this. It does not hit the x-axis. But how many steps away is it? It's one step away. And that's why we've got one I in the problem, because the square root of 1 is one step away. If the vertex was 9 steps above the x-axis, then we'd have a 3i and a -3i in our imaginary plane. Okay, so that's kind of it for completing the square. The other nice thing about completing the square that I didn't have time to show you is that that's where the quadratic formula comes from. So the quadratic formula is not just some nasty thing that was, discovered by gods. It really is just you complete the square and solve for x, just like you saw me do in these examples. And if you do that, you get the quadratic formula. So please comment and let me know what's hard. We'll keep working on it.